Students, welcome to the chemistry class and welcome to the second part of the chapter aldehyde, ketone and carboxylic acids. Okay, so in this part we will discuss about the general methods of preparation of aliphatic aldehyde and ketones. So the first method is from alcohols. So from alcohols the aldehydes were obtained by oxidation method. Aldehyde can be obtained by controlled oxidation of primary alcohol. Okay, so this CH3CH2OH oxidized in presence of K2Cr2O7. So this primary alcohol CH2OH group is converted into CHO group. Means alcoholic group will convert into aldehydic group. So by this method you can prepare an aldehyde. Other secondary alcohol by oxidation will convert into ketones, and secondary alcohol other type the examples, then it will also convert into ketones. Okay, so as we know that by oxidation this group will convert into CO group. Okay, now by electrolytic dehydration of alcohols, so aldehyde how can be obtained? So methyl alcohol in presence of copper converted into SCHO. What happens? This OH, H, 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 and this alcohol. So in the presence of basically copper catalyst, these two hydrogens were released from here and it will form HCHO, that is known as the formaldehyde. Okay, so by reduction of alcohols you can obtain the aldehydes, and ketones also obtained by the reduction of alcohols, but in this case you will use primary alcohol, and in this case the secondary alcohol they will gives ketone on the reduction. And third, by carboxylic acids. So from carboxylic acid, by dry distillation of calcium salt of carboxylic acid, if you will take the calcium salt of carboxylic acid and formic acid, then calcium formate and calcium acetate, then it gives 2 mole of acetaldehyde or basically aldehyde. For example, here you can take calcium methionate, and here you can take the methanol plus calcium carbonate. Means if you take 2 moles of this calcium methanoate, then after heating it gives to 1 mole of methanol, means methanol means formaldehyde and calcium carbonate. So by this method you can prepare. Second, by catalytic decomposition of carboxylic acid. Okay, so aldehydes are obtained when mixture of vapors of carboxylic acid and formic acid is synthesized in catalytic decomposition in presence of MnO. So when carboxylic acid and formic acid will react in presence of manganese dioxide, then 1 mole of aldehyde will prepared and carbon dioxide and water will be released. Okay, so it is the basic reaction. If you take H at the place of R, then it will form formaldehyde. Okay, so the basic reaction. Now symmetrical ketones. How can you prepare the symmetrical ketones? So for symmetrical ketones, 2 moles of carboxylic acid you will take and react with in presence of manganese dioxide, then it gives RCOOR. Okay, so it is known as the symmetrical. At the place of R you can take CH3, you can take CH3, and the reaction will come same, but at the place of R and R dash there will be methyl group will attached. Okay, so these are the methods. Now from acid chloride. So acid chloride react with H2 in presence of palladium oblique barium sulfate boiling xylene, then it gives aldehyde. Basically 1 H and 1 Cl will release from here, and H will go and attach to this, means it will form RCOH. This is this compound. Okay, so here you can see that hydrogen in presence of palladium and barium sulfate gives an aldehyde, and this reaction is commonly known as Rosen-Munn reaction. It is very important reaction. Okay, now come to from Grignard reagent. So how you can prepare the aldehyde by Grignard reagents? So firstly use the aldehyde when cyanide is react with Grignard reagent, that is RMgX, then it gives N aldehyde. What happens? This group will break C plus and N minus, and alkyl group also break R minus and MgX plus, and both opposite charge will go and attached, means R go to this carbon and attached here, or remaining Ms go to this nitrogen atom and attached with Mgx. Okay, now by hydrolysis means OH2, OH2, okay, OH2, OH2. Hydrolysis means reaction with this. Then it will break from here. Oxygen will gives HCOR from this, and ammonia gas released, and with it MgOH ka whole X will also formed. So by the reaction of Grignard reagent with any of cyanide, you can prepare aldehyde. And for ketone, you will take alkyl cyanide and you will get the ketone. Same reaction and same mechanism will perform here. But here, what is the difference? There is hydrogen is present. There is in reactant there is hydrogen. Then it gives aldehyde. And if you will take alkyl group at the place of hydrogen, then it gives ketone. Okay. Now, other examples are given here from alkanes. So, alkanes, how can you obtain? By the reaction of ozone, means ozonolysis. It is very important reaction. It is an alkene, CH2 double CH2 react with ozone. Then what happens? These two bonds will break and 3 oxygen will get attached. And this structure will form, that is known as ozonide. And after the reaction of zinc in presence of water, it will break from here and it will gives 2 mole of SCHO plus Zn oxide, zinc oxide. So, here you can see that by the reaction of ethine with ozone, we will obtain the aldehyde. So, it is a very important reaction. Other example you can also watch. You can take propene, same reaction will perform and form 1 mole of ethanol and 1 mole of methanol. Okay, and for the ketones, you have to take this type of compound like 2-methyl butene, and the next mechanism will be same, and 1 mole of ethanol and 1 mole of acetone will form. Okay, so it is the basic mechanism which apply for all the reactions for the preparation of aldehyde and ketone both. Next, from gem dihalides. What is the gem dihalides? Means this is the CH3 CaCO2, there is one dichloroethane react with water, then it gives an unstable compound CH3CHOH, and after that there is a water molecule will release and form CH3CHO. Okay, same condition will for ketones. You will obtain ketone by this reaction also. Okay. Next, from alkynes. Now, alkynes on hydrolysis in presence of dilute H2SO4 and mercurous sulfate gives vinyl alcohol, and this vinyl alcohol after losing hydrogen converted into the acetaldehyde. Okay, and the other matter, the oxidation with CrO2Cl2. Okay, so it will come in aromatic system. We are studied here for aliphatic. Now, come at the general method of preparation for aromatic aldehyde and ketones. So, here also you will use the by oxidation method. So, in oxidation method, what happens? Toluene, in which CH3 group present with benzene ring in presence of chromium oxide give this intermediate product, and after the reaction of this, it will convert into CHO. Okay. So, it is the basic reaction. Here what happens? This CH3 CH2O, CH3 C double bond O, O C double bond O CH3. Okay. This will break from here and 2 moles of CH3COO are formed, which will go and attach to this methyl group and form this intermediate condition. And after the hydrolysis, means H2HOH, simply OH2, it will break from here, 2 hydrogen will go with this, give 2 mole of acetic acid, 2 mole of acetic acid and 1 mole of benzaldehyde. So it is the mechanism for this reaction. Okay, next oxidation with K2Cr2A7. Same reaction will perform. There was CrO3 was given as a reagent, and here it will take CrO2Cl2 is take as a reagent. Then this group will convert into this intermediate condition, and finally by hydrolysis H2O, this will break from here or gives benzaldehyde. Okay, so this is the condition and the preparation of the aromatic bases. And next and very important reaction by Riemann-Tiemann reaction, in which phenol is reacted with presence of chloroform CaCl3 plus NaOH gives this intermediate product, and after acid catalysis gives aldehyde. Okay, ortho and para both product will form in this section. Okay, thank you, have a nice day.